Hello 10th graders, this is Miss Miriam and this is the 4th online math lesson from MIS. Using sine to find the area of a triangle is our lesson. Keep your calculator and a piece of paper beside you as you go through this video and stay focused. Let us try to find the area of this triangle. We know that the area of any triangle is equal to half times its base times its height. And we also know that base and height are perpendicular, or the height is perpendicular to the base. Now, let B be the base of this triangle, and let us draw the height h. As you can see, we will have two right-angled triangles. Let us look at the triangle that contains the angle C. The height is opposite to the angle C. A is the hypotenuse. This means that h, or the height, is equal to A sine C. The area of this triangle ABC is equal to half times the base, which is B, the height h, which is A sine C. So the area is equal to half times B times A times sine C. And this can be rearranged to half AB sine C. Using the same way, you can show that the area of this triangle is equal to half BC sine A or half AC sine B. So, to find the area of any triangle without using the height, you need an angle and its two sides. In other words, two sides and the angle between them. Let us apply the rule to find the area of a triangle ABC with angle BAC is equal to 86 degrees, AC is equal to 6.7 centimeter, and the AB is equal to 8 centimeter. Let us draw the triangle, and as you can see, angle BAC is between the two given sides. This means that we can apply the sine rule straight away to find the area of this triangle. So the area of this triangle is equal to half times 6.7 times 8 times sine 86 degrees. With a calculator, you find that the area of this triangle is equal to 26.734, etc. Rounding your answer to three significant figures, it will be 26.7 squared centimeters. The area of triangle LMN is 113 squared centimeters. LM is equal to 16 centimeters and MN is equal to 21 centimeters. Calculate the measure of angle LMN. The first thing we must make sure of is this angle that we want to find its measure is between those two sides so that we can use the sine rule. You have two ways to check, either by drawing it or by noticing the vertex of the angle. The letter in the middle is M, is the vertex of the angle. And you can notice that we have MN and LM as sides. This means that those two sides are extended from the point M. So those two sides are the sides of the angle. The angles between them. Good. This means that now we can apply the area rule to find the angle. Before we start, let me mark the angle as X. The area of the triangle is equal to half times 16 times 21 times sine x. The area of the triangle is 113. This means that 113 is equal to 168 times sine x, and 168 is half times 16 times 21. Sine x is equal to 113 divided by 168. Use your calculator to find x by finding sine inverse 113 over 336. Find that x is equal to 42.269, etc. Rounding to one decimal place, the measure of the angle LMN will be 42.3 degrees. This question is the last question in this video. It contains three parts. I will solve the first two, and I'll leave the third as a homework. The question says that The diagram shows the dimensions of a four-sided field. We have A, B, C, D, a four-sided field, and as you can see we have the length of the four sides, and we have one of the angles. Part A says that show that the length of BD is 66 meters to the nearest meter. The first thing we must do is to draw the diagonal BD. Look inside the triangle ABD. Two sides and the angle between them are known. Well, two sides and the angle between them remind us of two things. Either finding the area of a triangle using sine, which is of course not the thing that we must use because we want to find the length of a side, not the area of the triangle, or using the cosine rule to find the length of a side. Let x be the length of BD. Then x squared is equal to 25 squared plus 73 squared minus 2 times 25 times 73 cosine 65. Use your calculator and the square root function to find that x is equal to 66.418, etc. Round your answer to three significant figures. X will be 66.4. So the length of BD is 66.4 meters. Part B says that calculate the size of angle C. Let us look at the triangle BCD. As you can see, we have the length of the three sides, right? This means that we can use the cosine rule to find the angle. Cosine C is equal to 35 squared plus 42 squared minus 66.4 squared divided by 2 times 35 times 42. Use your calculator and cosine inverse, and you'll find that the measure of angle C is equal to 118.9 degrees rounded to one decimal place.